So the question over here is combination sum. Now the overall idea of this question is that we want every combination of candidates that sums up to target, and numbers can repeat. So over here it says that the same number may be chosen from candidates an unlimited number of times. So we are going to use backtracking again, and what backtracking does is that it builds up a combination one number at a time, and whenever the running total gets too far or hits their target exactly, it stops and backs up to try a different choice. So I'll go through the code. We start the same way we do with backtracking, which is we start with result empty array. That's what we are going to return in the end. And then we will start with writing our backtracking function. So this is a helper function, and this is what actually does the searching, and it takes in 3 arguments. The first one is start, which is the earliest index in candidates we are allowed to pick from on this call. Then we have remaining. So how much is still left to reach the target? So this will start from target, and then it keeps shrinking as we add numbers, and then the path, which is the combination that we have built so far. Now, over this block, so if remaining is left to reach, path sums exactly to the target, so it's a valid answer. And we append the path, but we append a copy. So this is the syntax to declare a copy. And because path itself keeps getting mutated as we continue searching, without the copy, every saved result would later be emptied out. Now, if we overshot, so this particular branch that we are looking at is dead, so we just abandon it. So this was our edge case, and then the for loop. So this is the heart of this algorithm. Now for each candidate from start onward, we will do 3 things. First is choose, then we explore, then we unchoose. I've explained it in a different video as well. So choose is when we add candidates to the path over here. Then we are exploring. So we are recursing to keep building on that choice, and then subtracting its value from the remaining. Now over here, also notice that we are recursing I and not I plus 1. In other backtracking solutions, we have, when we are recursing, we always say I plus 1. But over here, we are saying I because the same candidate can be picked again on the next level, because it allows us to reuse the numbers. And also, we start at the start. We start this loop at start and never before it. And once we have moved past index I, we never look back. So that's what's stopping. Like, for example, if you have 3,2 from showing up as a separate combination from 2,3, for instance. And then, yes, over here we are unchoosing, which is popping. So it removes, and we can cleanly try the next candidate. At the end, we start from 0, pass in target, empty array, and return the result.